All right. So we have a following function that is a polynomial. And something we know about these polynomials is they are smooth curves. So for example, you will go something like this, or then so it does not have a corner, so it does not corner, and it does not maybe jump, for example, right? So we keep this in mind. So when we graph, we don't want to say, hey, there is a corner here, or there is a twist, or we're jumping. And also, if for some reason the graph does not intersect, if we know it intersects at this point, then it does. But if it doesn't, then we're not supposed to make it intersect. So we will see these details, but maybe we'll get a darker color. So if we look at, first of all, here 1 and 2 and 2, so if we add these, you get 5. So it is an odd degree. An odd degree means that the graph is supposed to be looking this way for the end behavior. It falls towards the left and it rises towards the right. That's for some A positive. Then we will inspect A here. It is -1, which is negative. And if in the event that you have a negative leading coefficient, then it will switch around. It will be rising on the left and falling towards the right. So this idea has to do with the end behavior, which what will the graph will do, and this leading coefficient takes care of that picture. All right, so maybe we'll slow down a little bit here, so think about it a little bit, because if the degree is even, then we have a different story. So maybe we'll talk about that later on. So yes, so if you've done examples, now this is a reinforcement. If you haven't done any examples, then maybe after this one you want to try the same problem multiple times, so you see different instances for the problem. So choose the end behavior of the graph. We will say, since this is negative, it will rise on the left, and it will fall on the right. Then the next question is where does it cross the x-axis or the zeros? Well, let's clean this now so we can talk about this part here. We go back to the function. Then we need to inspect each zero, which you know, if you do like a zero product property, because this is a factored form. So if you set f of x to 0, which, you know, the zeros also means x-intercepts. And we talked about the x-intercepts means you will use y equals 0, which is in this case f of x is 0. So if you put 0 here, then that means these factors, one of them is 0 or others are 0. So we will set x minus 1 to 0, and it will give us x equal 1. Then you will set x minus 2 to 0, and it will give you x equal 2. And you will set x plus 1 to 0, and it gives you -1. And the multiplicity here is x minus 1 is 1 time, so the multiplicity is 1. And x minus 2, the multiplicity is 2. You know, probably just quick review on it, it means twice. So if you set these to 0, you have 2 and 2 twice. So that's the multiplicity of 2. So now the idea of crossing and touching, Crossing happens when this multiplicity here is odd. So if the multiplicity is odd, then it's supposed to be crossing the x-axis, and you will cross it either if you think about it like lines with a negative slope or a positive slope. And if this multiplicity is even, then it's gonna touch, not cross, and it will either, just like the parabola, either it will open down or open up. So these are the zeros and what shapes. All right, so for crossing we have a 1, so we will cross at 1. For touching it's 2 and -1, so we can say -1 and 2. All right, so that's how we figure out that one. For y-intercept, we use the other image, which is y-intercept x equals 0, and that's it. And so if to figure out that, we clean this to start a new one. So x is 0, this is out, just say this is out, this is out. So you get used to seeing it if it's 0 just that way. So you have -2 squared, which is a 4, and you have 1 square, and you have a -1 and a negative. So the whole thing is 4 multiplied. All right. So we're going back to the function to figure out these. Now we need to put these together in order to graph. So why did we need the end behavior and all this? So so maybe we'll just bring it a little bit down this way. So the end behavior is telling us the idea of rising on the left and falling towards the right. And we also have some x-intercepts, -1 and 1 and 2. So, and we said that this has to be a smooth curve. So, so since if you start from the left, then it's supposed to be going up this way, which means from here it should take off this way, right, towards the left. So if at -1, if it's touching, then it makes sense to say something like this, right? Because you want it to continue its way there, right? Then we have the y-intercept is just a point there. Let's look at the far right. We want it to come down, so for the 2, it makes sense for it to be this way instead up. And so at 2, we check it's a touch, so it's supposed to be like this. And since at 1, now at 1 it needs to cross, so this part is here, so it'll be something like this. So like a negative slope there. So it needs to go through the y-intercept. So kind of we see that, so maybe we'll try to do a better job here. So at this point, I think when you you're gonna set these values, and you tell it to graph, and it graphs, right? Then for us, we're just gonna go ahead and try to graph it this way. And here, for some reason, this is not picking up, so we'll make sure it picks up. Here we go. Not perfect, but not perfect, but you're getting the idea of the graph, right? So it's touching and it's going up that way. And we'll put an arrow, which means you continue to go that way, and we'll put an arrow here just to say that it's going. Of course, this has to be a smooth curve. For some reason, this pen is not picking up right now. So one thing we didn't talk about here, that the degree is 5. So you will expect this thing to have 5 minus 1 turning point. And let's check if that's happening there. Here is 1 turning point, and 2, and 3, and 4. 5 minus 1 is 4. So yeah, so this looks correct. Everything that we need. In this course, we're not discussing these terms exactly where they are and all that stuff, but we're trying to get a better understanding of how everything come together. And if you have a graph, if you have the function, you can have a good idea on the graph. And of course, also, if you look at some graph, you will have an understanding to it. All right. So we'll do next ones in other videos, but this one is kind of separate, so we will finish here.